Okay, I'm going to start with number 2. I guess I can't erase this. So let's go to this. We're going to start with number 2. So it says, find the tangent line approximation of this function near x equals 1. So let's recall. Our tangent line approximation, and if we're looking at x equals 1, or really a equals 1 here, so it's going to be f of 1 plus f prime of 1, x minus 1, right? Okay, so what we need is to take this here. So if I have p of x equals 1 plus 1 to the k, where k is a positive constant, that just means that'll be 1. So p of 1, I should say, is 2. Now let's take the derivative. If p of x equals 1 plus x to the k, p prime of x equals k times x to the k minus 1, right? And if we're looking at that at 1 equals k, oops, sorry, 1 to the k minus 1, which is just 1, oh lordy, equals k, doesn't it? So p prime of 1 equals k. So my linear approximation looks like this. F of 1, which is 2, plus f prime of 1, which is k, x minus 1. That is the linear line, tangent line approximation. Okay? Now, approximate the value of this using your answer. Well, if we compare px equals 1 plus x to the k to this, 1 plus square root of 0.95, well here x equals 0.95, doesn't it? And k is equal to 1/2, because the square root of 0.95 can be written like 0.95 is x raised to the 1/2. So we will use these to approximate. Okay, so our approximation at 0.95 equals 2 plus k, which is 1/2, times 0.95 minus 1. 2 plus 1/2 times negative 0.05. Okay, and that equals 1.975. So that's our linear, our approximation of the value 1 plus the square root of 0.95. Now it says determine whether your approximation in part B is an overestimate or an underestimate. Where there's two ways to look at that. If we look at x to the square root, if we look at it like this, now that we know that k is a square root, we look at this. Now this graph is simply the square root graph shifted up 1. The square root graph looks like this. Okay, can't put any negatives under there, so it doesn't, its domain really is x greater than or equal to 0. And it looks like this, which is concave down its whole time. Okay, so we think it's going to be concave down, and I'll test it another way. What if I go back and say, now that I know p of x looks like this, 1 plus x to the 0.5, I'm going to take the first derivative, which is 0.5x to the minus 0.5, and I'll take the second derivative, minus 0.25x to the minus 1.5, which is 3/2, okay, which looks like negative 0.25 over x to the 3/2. X to the 3/2 is saying you're going to take x to the third and take the square root of it. So again, you can only use positives. This will never be equal to 0 is what I'm trying to get at. It'll never be equal to 0, so there are no inflection points. And if I can only put positive numbers in here because it is a square root, this denominator will always be positive, so the overall thing is always negative, so it's concave down. If it's concave down, that means the tangent line is above, and we have an overestimate. Since we're using